Hello everybody. We are going to start a new chapter called coordinate geometry. In this lesson we will be studying about distance formula, the distance between 2 points in the coordinate plane. We will also study how to find the areas of triangles in the coordinate plane. So welcome to the lesson. Before we get into understanding the concepts presented in this lesson, let's first review our basics. We know what's a coordinate plane, the x-axis and the y-axis. Any point, the distance from the y-axis is called the x-coordinate. For example, if we have a point somewhere here, the distance from the y-axis, this is called the x-coordinate. It is also called as the abscissa. And the distance from the x-axis, that is the y-coordinate, which is called the ordinate. So every point on the coordinate plane will have an x and a y value, and any point on the x-axis will have x, 0, because the value of y is 0. This is called the x-intercept. And any point on the y-axis, anywhere on the y-axis, this will have x as 0 and the y value. This is called the y-intercept. So this is x-intercept and this is y-intercept. Y-intercept. So this is the basics of what we have learned in our lower grades. In fact, coordinate geometry is the study of geometry using algebra, and it helps us understand algebra with the help of geometry. This is the reason why coordinate geometry is widely used in applications of physics, engineering, navigation, seismology, and even in arts. So this is a very important lesson. Focus on the concepts presented in the lesson. Let's try to figure out what is the distance formula. Let there be 2 points P and Q, and the coordinates of P in general be x1, y1, and the coordinates of Q be x2, y2. Let us join them and form a triangle as PQT, and at angle T it is 90 degrees. So, can we now figure out what is PT? From here to here is x1, and from here to here is x2. So PT is going to be x2 minus x1. So PT is x2 minus x1. Okay, let's keep that as it is. Can you figure out what is QT? From here to here is y1, and from here to here is y2. So QT is going to be y2 minus y1. So it's going to be y2 minus y1. Now, is this a right angle triangle? PQT. In order to find PQ, can I use the Pythagoras theorem? We know what is the Pythagoras theorem. PQ squared is going to be equal to x2 minus x1 the whole squared plus y2 minus y1 the whole squared. If I take square roots on both sides, I get PQ is equal to square root of x2 minus x1 the whole squared plus y2 minus y1 the whole square. This is the distance between any 2 points on the coordinate plane. This is called the distance formula. Using the distance formula, let's work out some of the problems. Let's try this. Do the points 3, 2, -2, -3 and 2, 3 form a triangle? If so, name the type of triangle forms. How can you say that 3 points form a triangle? When do you say that? When the sum of 2 sides of a triangle is greater than the third side, then we say that the 3 points form a triangle. So, in this question now we need to find the distance between 2 points, taking 2 at a time. So, let us label the points as P, Q, R. Let us label this as P, and let us label this point as Q, and let us label this as R. Can we figure out what is the distance PQ? Equal to, apply the distance formula, square root of x2 minus x1 the whole squared. What is x2? Minus 2 minus x1, which is 3, the whole squared, plus y2 minus y1 the whole squared. Y2 is minus 3 minus y1 minus 2 the whole square. And how much is that going to be? Square root of, this is going to be 5 squared plus 5 squared, and that is going to be square root of 50. 25, 25 and square root of 50, and which is approximately 7.07. 7.07 approximately. Now, can we figure out what is QR? QR. Now, in this x1 y1, x2 y2. So, we will apply it in the formula, distance formula. Square root of x2 minus x1 the whole square. We are looking at QR now. x2 minus x1, 2 minus minus 2 becomes plus 2 the whole square, plus y2 minus y1 the whole square. 3 minus minus 3 becomes plus 3 the whole square, and that is going to be equal to square root of 4 squared plus 6 squared. And how much is that? Which is square root 52, and that is going to be approximately 7.21, approximately 7.21. Now, let us figure out what is PR. PR, when we are taking these 2 points, then this is x1 y1, this is x2 y2, and we can use it in the distance formula. So, square root of x2 minus x1 the whole square, 2 minus 3 the whole square, plus y2 minus y1 the whole square. Y2 is 3 minus y1 is 2 the whole square, and which is going to be equal to square root of 1 minus 1 squared is going to be 1, and again over here it is going to be 1, which is going to be square root 2, which is approximately 1.41. So, when do we say that the 3 points can form a triangle? When the sum of 2 sides is greater than the third side, we say that they form a triangle. And if you observe here, the sum of 2 distances is greater than the third distance. Therefore, these 3 points form a triangle. Let's try this. Show that the points 1, 7, 4, 2, -1, -1 and 4, -4 and 4 are the vertices of a square. First, let us label these points as A, B, C, D. This is A, B, C and D. When can 4 points become a square? When the distance between the 2 points are equal. Say AB should be equal to BC, should be equal to CD and should be equal to DA. And also the diagonals of the square have to be equal. AC should be equal to BD. So let's figure out applying the distance formula. And what is the distance formula? It is square root of x2 minus x1 the whole squared plus y2 minus y1 the whole square. You can also write it as x1 minus x2. It doesn't matter whether it's x2 minus x1 or x1 minus x2. So let's look at the distance formulas now. So if you apply the distance formula, AB is going to be x1 minus x2 the whole square plus y1 minus y2 the whole square, and that's going to give you square root 34. Now let's find the distance BC. This is x1, y1, x2, y2. So BC will then be, if you apply the distance formula, square root of x1 minus 1, that's going to become plus 1 the whole square, plus y2 minus 1, that's going to become plus 1 the whole square, and that's going to be square root 34. Now let's find out the distance CD. Same way, let's find out the distance DA. Fine. So are all the sides equal? Yes, they are. Now let us find out what is the distance, the diagonal AC and the diagonal BD equal to. So the diagonal AC is going to be square root 68 if you apply the distance formula, and the diagonal BD is also going to be square root 68. So for 4 points to form a square, the distance between those 2 points should be equal and the distance of the diagonals have to be equal, which is the case in this problem. Therefore, these points are the vertices of a square. So great going. You need to just remember the formula and apply the formula in the problem without making any algebraic mistakes. Let's try this. The figure shows the arrangement of desks in a classroom. Ashima, Bharti and Camilla are seated at A 3,1, 6,4 and 8,6 respectively. Do you think they are seated in a line? Give reasons for your answer. Now let's try to understand the logic. If they are seated in a line, then AB plus BC should be equal to AC. Only then these 3 will be in a line. Otherwise, they will not be in a line. So we need to find the distance AB, we need to find the distance BC, and then we need to find the distance AC, and then check whether AB plus BC is going to be equal to AC. So let's apply the distance formula and find out what's AB. AB is going to be 3 root 2. Remember the distance formula, square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. So for AB, x2 minus x1 the whole squared plus y2 minus y1 the whole squared, and that's going to be 3 root 2. And for BC, apply the distance formula and you get 2 root 2. and for AC apply the distance formula and you get 5 root 2. Now let's check how much is AB plus BC. AB plus BC. That should be equal to AC. We have to check that. So AB plus BC. AB is 3 root 2 and BC is 2 root 2. Add them up, it's 5 root 2. It is same as AC. So therefore, these 3 points are collinear. Collinear means they are on the same straight line. So they are seated in a line. Great. Just apply the distance formula carefully and then you can solve such type of problems. Let's try this. Find a relation between x and y such that the points xy is equidistant from the points 7, 1 and 3, 5. So let's label them as this is A, this is B and this is P. And let us represent this problem diagrammatically so that it is easy for us to work it out. Since P is equidistant from A and B, that means AP will be equal to BP. So we have an equation AP will be equal to BP. Now we can figure out the distance AP by applying the distance formula and BP by applying the distance formula for BP, and that is going to be square root of x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to BP x minus 3 the whole square plus y minus 3 the whole square. Now we can simplify it, remove the square roots by squaring both sides. So what happens? We get, if we square both sides and then square root gets cancelled with a square, and we are left with x minus y the whole squared plus y minus 1 the whole squared equal to x minus 3 the whole squared plus y minus 5 the whole squared. Is this in the form a minus b the whole squared, which is nothing but a squared minus 2ab plus b squared? Same thing we can apply for all these, and what do we get? So if you expand a minus b the whole squared for these terms, you get x squared minus 14x plus 49. That's for this. Plus y minus 1 the whole square, when you expand, you get this, equals x minus 3 the whole squared, when you expand, you get this, and y minus 5 the whole squared, you get this. Now you can cancel out the common factors. X squared cancels with x squared, y squared cancels with y squared. Bring all the x terms on one side and the y terms on one side and bring the constants on the other side, and let's see what happens. So let's cancel off the like terms. X squared cancels with x squared, y squared cancels with y squared. Let's bring all the x terms and the y terms on one side of the equal sign and the constant terms on the other side of the equal sign. So minus 14x, and when I bring the minus 6x on this side, it will become plus 6x. And then I have minus 2y. I bring the minus 10y on this side, on the left hand side of the equal sign, it becomes plus 10y equal to 9 plus 25 is 34. So I have 34 on this side, and then 49 plus 1 is 50. I bring it on the other side of the equal sign, it becomes minus 50. So this is going to be minus 50. Now minus 14x plus 6x is minus 8x. Minus 2y plus 10y is plus 8y equal to 34 minus 50 is minus 16. Now we can divide it by negative 8 every term, because each term is divisible by 8. So what do we get? We get x minus y is equal to 2. This is the relationship of x and y which the problem was asking us to do. Great going. Step by step, apply the distance formula, simplify, and then find the answer. Let's try this problem. Find a point on the y-axis which is equidistant from the points A 6, 5 and B -4, 3. So if a point is on the y-axis, what will be the coordinates of that point? It's going to be 0, y. Remember that? Now this diagram doesn't really represent the points A and B, just to show you how the problem would look like. So now if the point P is equidistant from A and B, that means AP is going to be equal to BP. So AP is going to be equal to BP. We can apply the distance formula now. The point P is 0, y. So if we apply the distance formula, it's going to be square root of x2 minus x1 the whole squared, 6 minus 0 the whole squared, plus y2 minus y1 the whole squared, 5 minus y the whole squared, is equal to square root of BP. So minus 4 minus 0 the whole squared, plus 3 minus y the whole squared. We can take squares on both sides. What happens? The square root and the square gets cancelled. We are left with 6 minus 0 the whole square, which is 36, plus 5 minus y the whole square is equal to minus 4 the whole square is going to be 16, plus 3 minus y the whole square. For this, you can apply the formula a minus b the whole square. And then what will this look like? And then apply the formula a minus b the whole squared for this and see what this looks like. And it's going to look like this. 36 a squared plus b squared minus 2ab. That's the application of the formula. 16 plus a squared plus b squared minus 2ab. That's going to be this. Now add all the constant terms. Y squared cancels with y squared. Bring all the y's on one side of the equal sign. Bring all the constant terms on the other side of the equal sign. And then add the like terms. So what do you get? You get 4y is equal to 36. Therefore, y is going to be equal to 9. So the required point should be 0, y. We found y. So the required point is 0, 9, which will be equidistant from A and B. The diagram only helps you to understand where the point is, the point P is. So don't really worry about the diagram. So in summary, how do you find the distance between 2 points on a coordinate plane? If the point P is x1, y1 and point Q is x2, y2. Apply the distance formula, which is PQ is equal to square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. You can write x2 minus x1 as x1 minus x2 also. Why is that so? Because anyway the whole thing is getting squared. So even if you land up with a negative, when you square it, it's going to get positive. So great going. This completes the lesson on knowing what the distance formula is, and we have seen how to apply the distance formula in some of the problems. Remember this distance formula. For the upcoming videos, we will be learning more on using the distance formula in different kinds of problems. So thank you very much for watching this video. Please subscribe and share and join me in the mission. helping you learn. Thank you.